Okay, now I want to consider sketching y equals a tangent of bx, and I'm going to limit myself to just one period of the functions, as because if we know what's going on for one period of the function, we know what's going on in general. Another thing is I'm going to think about specific instances or examples of what this a does and what this b does. So we're going to start with our tangent function. Okay, we have y equals the tangent of x, and this period is pi. So 1/4 of the period is pi over 4. And this essentially tells me where I want to have my tick marks to be pi over 4 apart. So I'm going to have something like this. And so here's my y-axis, my x-axis, pi over 4 apart. So I'm going to have, here's going to be 0, pi over 4, then pi over 2. Then I have a negative pi over 4, negative pi over 2. So these 5 points on the x-axis, we want to think what's going on with them for our y's. So first of all, we have these asymptotes here, right? At the extremes, and I know that my tangent of 0 is 0. If pi over 4, we're going to up here at 1. Negative pi over 4, we're down here at negative 1. And we have these asymptotes. So my tangent function is going to look sort of like this. And this would be my y equals the tangent of x, one period of it. Or I might think, what happens if I double this? What if I have y equals 2 tangent of x? My origin stays my origin. I'm doubling all the y values. So instead of being at 1 here at pi over 4, I'm going to be up here at 2. And instead of being at negative 1 here at negative pi over 4, I'm going to be down at negative 2. I still have these asymptotes. I'm still going through here. So I'm going to have something sort of like that. I'm just stretching vertically by this factor of 2. On the other hand, what if I have y equals, say, 1/3 tangent of x? Well, still at 0 I'm going to get 0, but now instead of being at 1 here, I'm going to be at a third. And instead of being at negative 1 here, I have to estimate I want to be at negative a third. So I don't want that. And so my graph is going to look something like that. So basically, the thing that A does, if A is positive, we're stretching our graph or shrinking the graph depending on if we're bigger than 1 or less than 1. The 2 here is stretching the graph vertically by factor 2. The 1/3 is uh, shrinking the graph by a factor 1/3. So now I consider, what if A is negative? What happens on one period of this? So just in general, if I negate a function, I'm going to be flipping about the x-axis because my y values switch when you negate them, right? So here's my tangent function is like so, right? This is y equals tangent of x. For the negative of the tangent, I'm going to be, so instead of pi over 4, I'm going to be doing this. So you have to use your imagination a little bit. But you see how these points work, because here at pi over 4 I'd have 1. This is y equals negative tangent of x. Instead of at 1 I'd have negative 1. So I would have a point here. And instead of negative 1 here, I'd have a point 1 here. So I'm still going through the origin. I'm going to have these asymptotes on the end points. of this interval from, what is this, negative pi over 2 to positive pi over 2, right? This is pi over 4, and then this was pi over 4 like so. So it's going to be decreasing. The slope here is going to be negative 1. It's not leveling out. It's going at this pace here. And then if I do want, I can do things like, what if y equals negative 2 tangent of x? Okay, so for this one, I could write the tangent and negate, or I can multiply this by 2. I'm going to have something like this now. Okay, so I can think of this twofold to get the blue graph here. Is one is I negate the function tangent, so that flips it about the x-axis, and then I stretch by a factor of 2. And that's how A is going to affect these things.